So we have learned the 5 axioms and 12 theorems in Boolean algebra. Let's apply it to the exercises that we have seen for several times during this course already. Let's just read that again. So we start with the problem definition or problem requirement specification. That Ben is having a picnic and he only enjoys it when there are no ants and it doesn't rain. Then we need to create a circuit for this. Okay. Then the first step that we have done over here, which is to create the truth table. So A is for ant and R is for rain. If no ant, no rain, then he enjoys it. All the rest will be not enjoying. Okay. Then from there we need to convert this into Boolean algebra equation. And there are two approaches that we can do. One is the product of sum, another one is the sum of product. And we're going to use the sum of product approach over here. Therefore, we first need to find the mean terms, again, which is the products of all the involving input, which is A and R over here, for each of the row, and it is evaluated to be 1, okay, for that row. So in this case, you will have it's not A and not R. Why? Because it's A and R the input, and it is product of them. And the next one is Y not over here because it's going to produce 1. Why? Because A is 0, so not A is 1. R is 0, so not R is 1. So 1 and 1 is 1. Very similar, we can find other mean terms over here. Now we apply the sum of products. Then it defines as the sum of all the mean terms where the output equal to 1. So we are looking at this row because that is the only row that the output equal to 1. Then we now have E equal to not A and not R. And from here, of course, we can now go ahead and wire the digital circuit for this. So we can wire it this way. So this one is A and not A. We're going to just outline the NOT gates. So this is A as the input and go through this NOT gate until this point you have NOT A. Very much similar. You have NOT R. This is R. It's going through the NOT gate until this point you have NOT R. Okay? Until this point you have NOT A. Until this point you have NOT R. And you end them together, which is a dot. You replace that dot by the AND gate. You're going to have your result as enjoyed or not. Okay. Now this one works. However, we'll say, can we do it better? The answer is yes. And right now you have the tools to do that already. And the first steps on this one is we're going to negate both sides. Okay, we negate this side and we negate that side too. Okay, then we apply the De Morgan law. On the right hand side, you'll see. So the De Morgan law saying not observer of the n is the same as not of the individual or together. So this is not of the individual. Okay, and you convert the n into or. So the next step is you'll see not A is A. That is involution, similar for R. So we'll have that not E is actually N or R. Much simpler right now, right? So it's only one logical operator, which is or. However, there is still one problem remaining over here, which is it's produced not E, but we want the E. Okay, therefore, again, we just negate both sides. Okay, so now we negate both sides. We'll say this, and this operator still is one operator, which is a NOR, which is not OR. And for this, we apply involution, it's become E. So we apply involution, it's become E. And again, the not OR operators is this one gate. So now we can produce it with the not OR gates like this. So it is more efficient if we use the not OR. Okay. So this is what we see that it is a much better solution applying Boolean algebra in this exercise. Okay. Now, This one is another example that you can apply the axioms or theorem that we have learned so far in order to prove the consensus theorem. Let's say you truth table. That one is that one is what I suggested earlier. You truth table, and this one you have 3 variables, so it have 8 rows for each side. So it's not that difficult at all. Only 8 rows. And if the left side produces the same output as the right side for every row, then they're the same. So this one is a consensus theorem. Because I ask you to prove this because this one probably is the most confusing one. Okay, the most difficult one to prove. Okay, and then how about proving it using other theorems? And one the way to do this is try to eliminate and get the CD over like because CD equal to BCD plus not BCD. This one is we're going to combine. You'll see B and not B over here, and with CD is the same. So you can eliminate the B, okay, out of BCD and also not BCD. It's become CD. Okay, so you can just use this one and try and solve this exercise. Okay, and next time we'll give some more exercises in applying these theorems as well.